So recall when we did Lewis Dot for ionic, metal gave to non-metal, opposite charges hold them together. However, just like I have written on the whiteboard, that's not what happens with a covalent bond. In a covalent bond, you have two non-metals that both, with fairly high electronegativities, try to gain electrons. But one can't take from the other, they have to share instead. So we have to show this in a new way. And that's what this sheet that you picked up on the way in is going to show you. Once again, there's 3 steps I have on there. Step number 1 says draw out the Lewis structures for the atoms listed. So, hydrogen. The Lewis structure for hydrogen is an H. How many electrons does hydrogen have? 1, right? It doesn't matter where you put that down. I'm going to put it right there. Second element is chlorine. How many valence outer electrons does chlorine have? 7. It's in the 7th column on the periodic table. 1, 2, 3, 4, 5, 6, 7. Again, it doesn't matter if your lone dot is on the left or it's on the bottom, wherever. The goal in bonding is to achieve stability. Stability is typically achieved when things are similar to noble gases in configuration, which means hydrogen, instead of having 1 electron, would be more stable if it were like helium with 2. Chlorine, instead of having 7 valence electrons, would be more stable if it was like argon and had 8. But you cannot have hydrogen just give to chlorine and say, hey, you win, congrats. Or chlorine do the exact opposite. Instead, just as I have up on the whiteboard, they share. Orbitals overlap. Step 2 on here says circle the unpaired electrons that will be shared between the atoms. That's this right here. Now, a typical Lewis dot isn't drawn with a circle around electrons. It's drawn with a line, and that's what step number 3 says. Redraw your compound using a line to show the bonded shared electrons. And then don't forget to add in the unbonded pairs of electrons. This would be the Lewis dot structure of HCl. Some people don't even do the circling. They just play connect the dots. Or they'll just draw the line right here. Because any line consists of 2 points connecting them. That line that I drew right here on the right-hand side of HCl is composed of 2 electrons being shared. Just like what I drew up on the board. So the big difference between ionic and covalent is in covalent we have kind of lines. We have a sharing of electrons. In ionic, one thing gave to the other, and it's opposite charges that hold them together. Now, what you can see in the bottom here is 4 other practice problems. I'd like to give you a moment to see if you can try to do this. Keep in mind, just like with last time with ionic, we need a final answer. Usually it helps by starting off with what you're given. So, for example, with the bromine, bromine has 1, 2, 3, 4, 5, 6, 7 electrons around it. Draw a second bromine, because it's Br2. Hydrogen, we already showed you for water, has 1. Oxygen has 6 valence electrons. Carbon has 4. You can see that there's 2 problems with carbon on the bottom. One which is CH4, which is methane. That's the gas that comes out of our gas jets. C3H8 is propane. That's what you use to grill out if you don't have a charcoal grill, if you have a gas grill. So take a few minutes to see if you can first figure out how to draw these things out using bonds. Circle lone electrons, connect the dots with a line. Whatever it might be, your goal is 8 outer electrons. So I have the 4 answers up on the board. And what I'd like to do is talk you through each of them in how they demonstrate the octet rule. Because that's one of the main reasons why we do Lewis structures at Chem 1 level is for that. If we look at Br2, remember that each line represents an extra electron from each. After all, bromine had 7 to start with. So if I kind of cover up the bromine on the left and look at only the bromine on the right, it has 2, 4, 6, 8 electrons around it. It has this bonded pair and what I call 3 unbonded pairs. If I look at the bromine on the left, same thing. 2, 4, 6, 8 from the bonded pair. Water. Now the shape that you make water isn't that important. If you wanted to put the hydrogens out like this, that's fine. Some of you right now are drawing curvy lines. So they're doing curves to connect everything. Straight lines is what we use, not zigzags and twirls and everything else to make things connect. Hydrogen has 1 bond on it, which means that counts for 2 electrons. Hydrogen is stable at 2 because it fills the 1s2 shell. Oxygen has 2, 4 from the bonds, 6, 8 from the unbonded pairs. It's at the octet. Methane, which is CH4, each carbon bonded 1 time. 2, 4, 6, 8 when you count the bonds. Hydrogen's already at the octet as well. And then on the bottom right is propane. Same sort of pattern, except for it's a longer chain. There's so much within chemistry that is long chains of carbon, and then what comes off of it. There's an entire discipline of chemistry called organic chemistry that's based upon carbon and what's coming off of it. Any biochemistry is dealing with carbon and what's coming off of it. When you talk about your DNA, carbon, other things coming off it. Because that twisted ladder, that double helix, is just those molecules and how they're attracted to each other through hydrogen bonding and things like that, which we'll eventually get to. But this is meant to be your introduction into a new way of showing Lewis dot structures. And what you have to remember is regardless of ionic versus covalent, the goal is still the same, 8 electrons. The difference now is that line in between each atom counts as 2 electrons. As I have up on the whiteboard, it's an overlapping of orbitals. What I have up on the board is what we would call single bonds. So it's 1 bond in between each thing. Now we have to work on today now for a good portion of the class, this is get you up and about if you want to be up and about, is the packet you picked up on the way in that was titled Lewis Dot Multiple Bonds.